Welcome to the Calculus and Vectors exam review for Unit 6, the natural logarithm. So we're going to review again just a couple of the details. There was a lot more stuff that we did, including curve sketching, but the general idea is how do you take the derivative of a logarithm, some of the little details that you have to remember when you're doing that. So we'll do a couple of questions to review some of those important details, but there's a lot more when you remember about the asymptotes and end behaviors of these and sketching them. Okay, but before we get to any of that, we have to talk about what the actual derivatives of these are, and there's actually four because they change depending on the base that you're in. Now the way we started with was d by dx of e to the x, but we'll do e to the u, and this is that kind of crazy one where the derivative is itself, but if you have another function, then you have to multiply by the derivative of that function as well. And then d by dx of ln of u is just 1 over u times u prime, or u prime over u, obviously, but we tend to write it this way. We've written everything else that way, so I'll write it that way. So that's if your base is the number e. Then we have those special cases, and that comes up a lot when we get to choose a base, that's the base we choose because it's so convenient. What about if you don't have a base of e? So if it is some other base, b, any other base that's not e, even if it is e, it just ends up, it simplifies. Okay, so it's b to the u times u prime times ln of b. And this is the part where if their base is e, ln of e is 1, so this is just a constant 1. Otherwise, it's some other constant that you actually have to take into account. So d by dx of log, so we're not doing ln now, it's log base b, because ln, actually I'm going to write this down, log base b of u, I'll do this up here, ln of x is the same thing as log base e of x, right? So this is just a special logarithm with a special base, and so this works out to 1 over u ln b times u prime. Okay, so these ones don't come up as much, so you got to remember the constant and where it goes and how to find it. That's always a bit of a trick. Remember those four, just like with trigonometry, you got to start with the basics. You got to know what the actual derivatives of these things are. So we'll do a couple of examples where we're differentiating, but we're doing first line only, so we don't have to simplify, we don't have to collect like terms. If there are monomials, maybe we'll clean that part up, because that's always good to talk about, but otherwise we will just do a first line. Okay, so y prime equals, now right away I see that this is product rule because I've got two things multiplied together here. So the derivative of the first thing is e to the negative 3x squared. That doesn't change, but then I multiply by the derivative of the exponent, so that's negative 6x, and then I multiply by the q, the other part, so that's ln of 2x, plus, and then we do the derivative of this, which is 1 over 2x times 2. In fact, I'll show it, 1 over 2x, and then the derivative of the argument, which is 2, and then times the first thing. Okay, so this was the derivative of this part here. Now we do e to the cos of x minus 6, and so again it's plus, that part doesn't change, e to the cos of x minus 6 times the derivative of the exponent. The derivative of cos is negative sign, and then there would be a times 1 here for the derivative of the angle of the trig part, but it's just 1, so we don't really have to worry about it. And there's really not much cleaning up to do here. You wouldn't be required to do this, but generally we write monomials out front, so I'm going to do that just because I am rewriting everything anyway. And the only thing I can really do is 2 divided by 2 is gone, so 1 over x. In fact, I'll write it this way. E to the negative 3x squared over x plus, actually we'll do minus sine x minus 6 e to the cos of x minus 6. But none of that was really all that important, except for, I suppose, those 2's was the only monomial cleanup that we had to do. You wouldn't deal with this as a negative exponent. You wouldn't worry about that. Remember, now, because we had this part, the e to the cos x minus 6 part, because we had that, it wouldn't be quite the same. But if you recall, when you're doing something like this, you always get a lot of factors coming out because e is its own derivative, so it ends up being common in all the different parts. So these are factorable in a very familiar, similar way every single time. So that's worth going back and reviewing in case this is a question that you have to simplify fully if you're solving, or you're just required to simplify fully. Otherwise, I believe that one is done. And we've got one more, and this one looks like quotient rule, and it looks like it's the one where we have not a base of e. Okay, not a base of e. So y prime equals derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. So the derivative of the top is 3 to the 4x squared, 4x squared minus 1. That looks like that's the whole exponent there. Okay, times the derivative of the exponent, which is 8x. For the derivative of 4x squared is 8x. Now this is the part that everybody forgets. I'm going to put it back in green. Times ln, I'll put it in green, times ln, ln of 3. Right? So that's a constant you have to take into account whenever you have a base other than e. And then all of that gets multiplied by the bottom, which is log base 4 of x cubed, minus, all of that was just the derivative of the top times the bottom, minus derivative of the bottom times the top. So this is going to be 1 over the argument, which is x cubed, times ln of 4, times the derivative of the argument, which is 3x squared, because it's x cubed, so 3x squared. And if you want, obviously, you can do that one step and put that up here, times the top. All over the bottom squared. Now, and don't forget the x to the pi. That's a strange one, not something we see. It has nothing to do with the rest of it. But how would you do this? This is a quirky one. It would be pi times x to the pi minus 1. This is one of those ones that it's not a constant. It's in terms of x, and it's pi, which is just a number. So it's just like doing x cubed. That becomes 3x to the 3 minus 1, which is 2. But instead it's pi x to the pi minus 1, which is not something we can simplify. We'd have to leave it as pi minus 1. Now, is there any simplifying that we can do here? Not really. I mean, again, we could bring the 8x out front. We could write this in a little bit of a nicer way, and we could put the 3x squared up on top. In fact, we could do some work with the x squared and the x cubed, but I'm not even going to bother rewriting it to work on that. This was really just about figuring out, I'm going to fix that part though, figuring out how you do a general derivative, a bit more work with the quotient rule, and when you are working with a base other than e, with logarithms and exponentials. Okay, so that was a quick overview of that stuff. The next one, is find dy by dx for this function. Now this is called logarithmic differentiation. If you remember, this has to be used when you have an x in the base and an x in the exponent. And there are other times where we use logarithmic differentiation as well. Generally, the idea would be sometimes when you have a crazy product rule and quotient rule and all kinds of stuff, it can be easier to do it with logarithmic differentiation. It would also definitely depend on the context of the question, what you're trying to accomplish. But it's a good tool to have in some cases. So we are going to, before we start, we're going to raise both sides. So we're going to take the ln of both sides. Okay, so I get ln of 2x minus 5 all to the x over 2. And if you remember, the nice thing about this, the whole point of this is I can use logarithmic rules to get x over 2 out in front. And now this is actually something I can take the derivative of, because before it wasn't. If I had an x in the base and in the exponent, there's no other way to do this that we know of. But now this is something I can take the derivative of. Before I move on, I just want to say you could use any base you want. We choose base e because it's the easiest one to work with. Okay, so this is product rule on the right, and we also have to do implicit differentiation with the ln y on the left. So the left side is 1 over y, whoops, got ahead of myself there, times dy by dx, that's the part that people will forget, equals, so this is 1/2 x, so the derivative of that is just a half. So the derivative of the first thing times the second plus the derivative of the second thing, which is 1 over 2x minus 5 times the derivative of what's inside there, so times 2 times the first thing, which is x over 2. I can see right away that these 2's are going to divide out. 2 and 2, there's one on top and one on bottom. And I can bring the y over, so dy by dx equals y times the ln of 2x minus 5 over 2 plus x over 2x minus 5. Now I can't remember if the instructions said this. They may not have, but this is what we always do. We leave it in explicit form because we know what y is. When you're dealing with trig, you rarely do, or the other ones we did, you rarely do. But this is y. So I can rewrite this in explicit form, which means in terms of x only, one single variable. So this ends up being 2x minus 5 to the x over 2 times this whole thing again, right? And that's it. So that is completed. I've tidied it up as much as I'm required. You don't have to do any more putting this into one fraction or anything like that. And I've put it back in explicit form. So that's logarithms. It's a simple overview of some of the basics that we did in that unit. But there are a few other key ideas that definitely should be reviewed. Like I said, the asymptotes and end behaviors. But at least we covered how to take the derivative of each of the 4 different types of expressions that you may encounter when dealing with logarithms and exponents.